very good morning to all. Let's move on to the last day of lecture series, GAN Biocomposites 2025. I would like to welcome Professor Alain for the first lecture. Over to you, sir.
Thank you. Bonjour. The class will be in French today. No, you prefer in English probably. So, yesterday evening, I discovered that you are not only very good scientist, but also excellent singer. So, congratulations. So, I will say some word about application of biocomposites, but also bionanocomposite or bionanoparticles in some case. It's not working. So, the advantage of biocomposites. So we already discussed part of this. The mechanical properties. So the mechanical properties reveal some medium high stiffness and excellent impact resistance. So meaning that the energy for breaking the material is high compared to glass fiber reinforced composites. Deformation properties and the dimensional stability. Another important parameter is sound insulation, and of course it will lead to specific application of biocomposite. So lightness is also important because we can have reduced thickness and weight. Of course, biocomposites are environmentally friendly. We can use natural and local resources, so it reduces the carbon footprint, reduce toxicity of material, and it's important also for the end of life for biodegradability or recyclability. Now regarding manufacturing, we have an excellent thermoformability, reduce production energy cost, and cost reduction. Remember that compare also to glass fiber, because glass fiber are mostly used for composite, natural fibers are less brittle. And aesthetic consideration are also important. So the global market size for natural fiber composite, so you have some data here. So it was over 364 or 5 million US dollar in 2024, and it is expected to be close to 1,000 million US dollar by 2037. The compound annual growth rate is about 7.5% during this period. Of course, this is important, but this is also the case for all the material, because you know that there is a growing population, growing needs also for this population, but this is an important consideration. In the year 2025, the industry size of natural fiber composite is evaluated to almost 388 million US dollar. Sorry, I cannot pass the slide. Can try? Ah, yes, it's clear. So, regarding the application sector for biocomposite, so it's mainly construction and automotive. You can see here, almost half of the market is for construction, and automotive is also important. So and some other markets are coming also. So the reason are quite obvious. In the case of construction, the important parameter is the weight, of course, but also sound insulation, which is also the case for automotive or for transportation in general. The weight is very important because if the weight is decreased, the consumption of gasoline is decreased, and sound insulation is also important. So you have some application here. The case of construction for automotive, so it's mainly inner panels which are made from this kind of biocomposite. So it's often polypropylene and natural fibers. And the nature of the natural fibers depends on the place where it is obtained. For example, in US, it's mainly kenaf. In France, it's mainly flax because they grow locally. There are some other examples of this application for automotive. And there are some other fields which I report here. Field of energy and impact absorption. So again, we take into account this high impact absorption of this kind of material for car fenders, bicycle helmet, and so on. So these are some other applications that can be found, and there is a growing demand for this kind of product, this kind of material, because you know that people is more and more close to natural product. Can be used in bicycle. There are also some bicycles which are made from only bamboo. There is no polymer. So you have here another application in flax, with flax fiber and the matrix, which can be PP, polypropylene, PLA, or polyamide 11. Also for alpine ski, which are made from hemp fibers. And also the impact resistance in this application is very important. So I will show you some opportunities for biocomposites, but also some points of attention. Opportunity number one, stiffness and density. This is very important. We mentioned it previously. Various natural fibers have mechanical properties which are similar to glass fiber. For example, in the case of flax and hemp, the modulus is close to the one of glass fiber, around 70 gigapascal. And the density is much lower, about half the density of glass fiber. One point is the strength. The strength of plant fiber is generally 2 or 3 times lower than that of glass fibers. So the elongation at break is higher, but the strength is lower, which can, of course, be a limit for some application. First point of attention, resistance to environmental conditions. Plant fiber, of course, are sensitive to fire and to water, which is not the case for glass fibers, which are highly resistant to fire. For biopolymer, resistance to UV, scratch, fire, temperature, and humidity depend on the material which is used, but also the additives that can be added to the formulation. Fiber treatment, the application of a biocoating and the choice of the right polymer can increase the resistance of biocomposite to environmental conditions, so mainly moisture conditions. But there are some examples where boats, kayak, and canoe are made from plant fiber based biocomposite, meaning that waterproofing is not really a problem. You have an example of a flax fiber bio-based epoxy boat. Opportunity number two, mechanical and acoustic damping. Also, we mentioned this previously. In terms of damping, plant fiber composite outperform glass and carbon fiber composites. Composites based on plant fiber can offer up to 10 times greater damping than conventional composites. The use of biocomposite represents an opportunity for some application where it's necessary to have high acoustic and mechanical material damping. Point of attention number two, the consistent quality of plant fiber. We already mentioned this point. When working with plant fiber, one of the problems is the variation in the structure of this material and also the chemical composition, meaning that we can have a variation in mechanical properties. The quality of plant fiber can be site or season specific. It is important for the supplier to regularly characterize the materials in order to guarantee the right properties to customer. So I already mentioned that usually the manufacturer of biocomposite use fibers that have been harvested during the last 5 years. So it's a mixture of this fiber in order to have less fluctuation in the properties. Opportunity number 3, available biopolymer. So this is for the matrix. There are partially or totally bio-based alternatives to thermoplastic and thermoset polymer, polylactic acid. I don't like this polymer, you know already. PHA, polyhydroxyalkanoate, biopolyester, and bioepoxy. Generally, thermoplastic biopolymer are fully bio-based. In the case of thermoset, there is a biological content that can vary from 20 to 100%. For example, yesterday we visited the company. I don't remember the name of the company. They use polyurethane. Polyurethane is made from polyol and isocyanate. So it's possible to have one of these components which is bio-based, meaning that the final material is partially bio-based. Point of attention during processing. So there are 2 points. The first one is the degradation temperature of plant fibers. The polymer used generally determines the process parameters. With plant fibers, the maximum fiber processing temperature must also be taken into account to avoid the degradation. For example, cellulose molecule generally degrade below 200, can degrade below 200 degrees Celsius. And of course, this limits the processing temperature to a maximum of 200 degrees. Point of attention number 4, pre-drying of plant fibers. Optimum adhesion between the fiber and the polymer matrix is of course very important to have a high quality composite. You know that plant fibers are hydrophilic, so it means that they can absorb moisture from the ambient air, and of course during processing, when increasing the temperature, it transforms to gas. Since they are combined with an often hydrophobic polymer, biocomposite processors generally pre-dry the fibers prior to adhesion or prior to processing before injection molding or extrusion, for example. Opportunity number 4, local value chain possibilities. This is an important point to avoid too much transportation. The possibility of setting up a local value chain is a major advantage of biocomposite. Knowledge and infrastructure are already well developed in northwestern France, western Belgium, and in the Netherlands. These countries are in advance for biocomposite. Flax in these countries has long been grown in this region, and fiber cultivation is also developing, offering similar processing possibilities. This initiative promotes local, intensively collaborative short chains, which are already in place and continue to develop. Point of attention number 5, the cost, which is of course important for the development of any material. Flax fiber are generally 3 or 5 times more expensive than glass fibers. It's not 2 times, you can see, it's much more. The lower density of flax fiber or any natural fiber can offset some of this extra cost. Biopolymers, so this is for the matrix, are also generally more expensive than conventional polymers, with wide price variation. So, it means that it is essential to increase the product value when using biocomposite. By, for example, improving the performance, the durability, the aesthetic. It's also important to consider the customer, which can, in some case, pay more for a natural product. Opportunity number 5, sustainable development. Reducing the environmental impact of materials used is a major advantage, of course, of biocomposite. The high renewable rate and possible absorption of CO2 during production, the possibility of enriching soil, and the more favorable prospect for waste disposal all reduce the impact on environment. So this needs to be considered also. So now for nanocellulose. So the nanoscale cellulose fibers, we have seen that there are, or there can be, some different applications because we have new properties. This is some data, but if you check another website, you have different data, so it's difficult to know exactly. But it is expected to grow very fast, as you can see here. It takes time because I think the first production of cellulose nanocrystals was in 2008, something like this, by Celluforce in Canada. And at the beginning, it was very difficult. They had the capacity to produce 1 ton of cellulose nanocrystals every day, sorry. So it's quite a lot. But the problem, of course, it's necessary to have a market. Many companies were interested in using this new material to improve the properties of their product, but the problem is the price. And for the company, they don't want to say too much about the price because they consider, probably, and we can understand, that if the application is, for example, for paper, it should be a low-cost additive. If it is for cosmetics, the price can be much higher. So it means that it's difficult to find applications. So there are now, I will show you, but at the beginning it was quite difficult. So remember, we can consider cellulose nanocrystals, cellulose nanofibrils, chemical treatment, acid hydrolysis, or mechanical treatment. We can have different applications. These are broadly for these two kinds of materials the application. And now we'll check for each sector what can be the product that can be developed and what are the reasons for using this nanocellulose to improve the properties of the product. So, composite. This is, of course, the most important market. So thin film, polymer thin film with increased strength and functionality can be obtained. When using, for example, glass fibers or natural fibers or carbon fibers, typically the diameter is 10, 20 micron. So it means that it's very difficult or impossible to obtain thin, for example, 1 micron thick coatings. In the case of nanoparticles, of course, we can prepare these coatings, this very thin coating, and with improved mechanical properties. So the key feature for application in composite are, of course, the high specific surface area. In fact, we have seen the same thing, but I present the properties and the impacted market. Now I start from the market and we check the key features, the interesting properties. So the high specific surface area for efficient stress transfer at the interface, high aspect ratio, which is important to have high mechanical properties, high stiffness, of course, of the nanoparticles. The lightweight is also important for composite application, and tunability of the surface. Food industry is another sector where nanocellulose can find many applications. For example, non-toxic strengthening or rheological modifier. We can change easily the properties, the rheological properties of many products in food industry using only a few % of mainly in this case cellulose nanofibrils. And you know that we cannot digest cellulose, meaning that it's a kind of diet product. So the key feature are, of course, the rheological behavior of nanocellulose gel, and it can be applied as a low-calorie substitute for different purposes. Carbohydrate additive used as thickener, flavor carrier, suspension stabilizer for different food products. Electronics is also an interesting market for the preparation of flexible circuits. What is interesting in this case is that, remember that nanopaper can be transparent. In this case, mainly nanofibrils are used because the cohesion of film or nanopaper prepared from cellulose nanocrystals is much lower than for nanofibrils. So the key feature, these nanopaper are transparent, lightweight, so are strong, and so it's generally obtained by casting evaporation of nanocellulose dispersion. Replacement of transparent plastic or glass. For example, Pioneer experimenting the use of nanocellulose in the production of thin, flexible electronic screens. IBM, another company, consider also nanocellulose, so in this case it's mainly bacterial cellulose or cellulose nanofibril for manufacturing components, flexible circuits for computer. Energy is also a big market, so it's possible to use nanocellulose for flexible batteries, lithium-ion batteries, and solar panels. The interesting properties are the mechanical properties, the transparency, again, and the low density of this material. You have an example on the right side of a portable paper solar cell, which is based on foldable and lightweight, transparent, conductive nanofiber paper. Paper on cardboard, of course, cellulose. Nanocellulose can be used, mainly cellulose nanofibrils again, can be used to improve the bonding between lignocellulosic fibers to provide a better dry and weight strength. It can also improve the barrier to grease, which can be important for packaging, and enhance the retention of as weight additive. Important parameter, mechanical properties, barrier properties. You can see here this photo of paper sheet, and a paper sheet that was coated with cellulose nanofibrils, and of course these thin filaments can bond the cellulose fibers or lignocellulosic fiber. Oops, sorry. Packaging, so it's related to paper and pulp industry. Alternative to widely used petroleum-based polymer can be used also as a binding agent. In this case, again, the mechanical properties are important. You can see that for many applications, the mechanical properties of nanocellulose is very important. But remember that this is the role of cellulose in nature. It improves the mechanical properties. So, of course, for packaging, barrier properties are important, and for some application, transparency is also important. This is an example of bacterial cellulose sunflower protein isolate. So, coatings, paint and varnish. This is also a big market. And so the key features are the mechanical properties, scratch resistance, which is important, of course, for the final product, stabilizing and thickening properties, shear thinning behavior. Because of this, when applying the paint, the viscosity is low, and when you stop the shear, the viscosity increases, meaning that there is a good adhesion on the wall. Thixotropic properties are also important, and maybe for some application, iridescent properties. You have here an example of a paint that contains highly fibrillate cellulose, so it's not really cellulose nanofibrils, because for some applications, so it's not necessary to have a very high degree of fibrillation. This is manufactured by SAPI, which is a company that produces nanocellulose. Detergent emulsions to replace synthetic adhesive. In this case, so it's more specific. The important characteristic is the self-assembly at water oil liquid interface. Remember that it's possible to prepare Pickering emulsion with these nanoparticles. The low toxicity is also important, and biocompatibility. This is an example. So in the text, I didn't know, I discovered when I prepared the slide, where they use nanocellulose as a stabilizer. Adhesive. So the objective, of course, is to improve the mechanical performance, mainly of wood adhesive, but also it limits the emission of volatile organic compounds, which are classically used as additive. Mechanical properties, again, are important to have a high strength of the adhesive, and the low toxicity is also important. Construction. So there are some studies in which nanocellulose has been added to concrete and to see what can be the improvement in the properties. It was shown that improved mechanical performance and degree of hydration of concrete substitute for glass can be obtained, and this nanocellulose can also be used as a substitute for glass and plastic for windows, because you can obtain transparent films, and it can also be used for thermal and acoustic insulation. Remember, it's possible to prepare highly porous aerogel or hydrogel or cryogel from cellulose nanofibers. So mechanical properties, again, are important. Transparency, so of course for this application, possibility to 3D printing, and ability to form cryogel or aerogel. Ink and printing. So it's possible to use cellulose nanofibrils to improve the writing quality by adding cellulose nanofibrils in ink for pens. It was done by Mitsubishi, for example. I have some of these pens. If you want, you can try. You can see that the writing is very smooth. And of course, in this case, the rheological behavior of nanocellulose gel is an important parameter. It has been shown also that when using a substrate which is made from nanocellulose, improved printing quality can be obtained. Filtration. Nanocellulose, in the form of aerogel, of course, can be used for desalination of seawater, filtration of blood cells during transfusion, trapping of dangerous chemicals, coloring dyes, metal ions, oil, organic solvent, etc. And we can obtain very light aerogel because the porosity is very high, and this aerogel can be reused. Again, the mechanical properties are important, the flexibility also, the high aspect ratio and specific surface area, because of course condition the surface that interact with the pollutant, reactive tunable surface chemistry to target a specific pollutant, for example, and the ability to form cryogel and aerogel. Biomedical, so it's another field. I think mainly for bacterial cellulose because it's pure cellulose, but cellulose nanofibrils or nanocrystal can also be used for some application. So it can be used for scaffold in tissue engineering, artificial skin and cartilage. In this case, it's mainly for bacterial cellulose, wound healing, vessel substitute. Mechanical properties, surface functionality, and biological properties are, of course, important. Low toxicity, biocompatibility, and biodegradability. Cosmetics. It's an important field. I had a project that finished 1 year ago with LVMH. I don't know if you know, but it's probably the biggest company in France. They have a huge research center. LV is for Louis Vuitton. M is for Mercier, which is a champagne brand. And H is for Hermes. So you understand that it's mainly a luxury company. The main partner of this company is Dior. They have a lot of money, as you can imagine. So I had a project with them, and they found a PhD thesis that was defended 1 year ago, more or less. And they were very interested in using cellulose nanocrystals, but for the optical properties, because they want to obtain, I can't say this now because it is patent, structural pigment of red color. So you imagine for which kind of application. But finally, the thesis starts just before the COVID period, meaning that the PhD student cannot start to work in the lab. And she read a lot. And when she come back, she tell me, your idea will not work. And finally, she used silica, hollow silica nanoparticle instead of cellulose. So it was working. It's not so bad, but... so, cosmetic, nanocellulose can be used as a rheological modifier, carrier for active ingredient, structuring agent, growth prospect for bio-based product. Mechanical properties, surface functionality, high water retention is also important for this application. Again, the biological properties, the rheological behavior, and in some case, iridescence properties. I had previously a project with L'Oréal, which is another company in the field of cosmetic, and they were interested by, what is the name? Nail paint with cellulose nanocrystals who have some iridescence. Hygiene. So nanocellulose can be used for colorless toilet paper, which is here. Improved resistance is obtained, it seems. Diaper with silver ion on surface of cellulose nanofibril to improve the deodorizing performance. Panty liner, napkins, water absorption pad, hard to tear balls cleaning sheet with improved surface properties. These properties are important, so we see more or less always the same properties for this kind of application. And I don't know why, but this is mainly developed in Japan by different companies which are producing cellulose nanofibril, also nanocrystals, Nippon paper and Dio paper. Defense. Nanocellulose can be used to develop bulletproof vest, highly dense and robust mat and films by evaporation of nanocellulose dispersion. Of course, the mechanical properties are important. The material is lightweight and antimicrobial. And so this has already been developed by this company. Acoustic. So for acoustic, the cellulose nanofibrils can be used, but it has been mainly developed with bacterial cellulose. Bacterial cellulose fibers or nanofibers can be used for the diaphragm of electroacoustic transductor, diaphragm of loudspeaker, or headphone. The key properties are reported here. Again, the mechanical properties, lightweight, dimensional stability, but also high internal loss, which is important for this kind of application. In fact, these membranes are usually made from paper, so it's also cellulose, of course, but much better properties are obtained when using bacterial cellulose. Oil industry. Oil industry, nanocellulose can be used as an additive in drilling fluid and flooding agent. Again, the rheological properties are of course important as well as the mechanical properties. Maybe we can read this. In this case, cellulose nanocrystals were used. So it was used to prepare drilling muds, and it was expect, or it is expect, to improve the cohesion even under extreme condition, reduce the volume of water and pressure which is necessary for the extraction of oil, enable resource extraction in area where this is not currently possible, and limit the damage to formation. You have an example here, so Cellforce, which is the most important producer of cellulose nanocrystals, but also cellulose nanofibrils, the Colville cellulose filaments, has received some money from the government, from Canada, to develop application of cellulose nanocrystals in the oil and gas sector, because they are producing, of course, oil. So, we have seen different applications. The most important application, you can see it's almost 1/3 is for composite, but pharmaceutical and cosmetic industries are also very important, and paper processing. So it represents almost 70% of the application. Now to conclude, the main advantage of biocomposites are mechanical properties, sound insulation, remember this is very important, lightness, of course, environmental friendliness, easy manufacturing, and aesthetic. The most promising markets for biocomposite or natural fibers are construction and automotive. The market impacted by nanocellulose are much broader because we have new properties, and so we have seen different sectors that can be or have already been impacted by nanocellulose: composite, food industry, electronics, energy, paper and cardboard, packaging, coating, detergent or emulsion, adhesive, construction, ink and printing, filtration, biomedical, cosmetics, hygiene, defense, acoustic, and oil industry. So some applications are already on the market, and some others are in the forecast phase. So, it's finished for my lecture. Thank you very much for your attention. I hope you have learned something. I hope you understand my French accent. And so you have my email address in case. And so you are welcome in Grenoble. It's called the capital of the French Alps. It's not a too big city, but it is surrounded by mountain, meaning that it can be very cold during winter, but it is very hot during summer. Thank you very much. And if you have any question.
Thank you, Professor Allen. The session is open for discussion. We're extremely honored to have you, sir.
Yes, I'm very happy to be here, you know. I like traveling in different countries and also in India, so it's not my first visit in India, but the last time was in January 2018. I was in Kochi. So it's a long time, more than 7 years.
Sir.
Yes.
Yeah, sir. So, which, according to you, which
Is it working?
Yes, sir.
Okay.
Now, yeah. Sir, according to you, which continent is right now more embedded with nanocellulose in market?
Which country?
Continent.
Which continent? Uh, I think it's. There are mainly three continents. I cannot say which one is in advance or not. It's mainly, in fact, it's mainly continents or countries for which the pulp and paper industry is important. Because, you know, now less and less people buy newspaper, for example, books and so on. So it means that the pulp and paper industries are in the difficult phase. And so they engage on nanocellulose because, of course, it is cellulose, they know cellulose. And so it's mainly, in terms of continents, so in America, it's mainly Canada and US. In Europe, it's mainly Scandinavian countries, Norway, Finland, Sweden, because they have a big pulp and paper industry. And in Asia, it's mainly Japan. But I don't know where it is now, but there is research institute in India. I don't know where. There is a research institute on cotton. You know it? Yes. And they contact me a few years ago because they start producing cellulose nanocrystal from cotton, of course. And they had a capacity of production of 10 kilograms per day. But when I tried this week to check, I didn't find anything. I don't know if they stop or... Yes. So for the continent, it's mainly these three continents, and in each continent, some specific countries. But I think that there are probably many others, because I know that, for example, in Malaysia, that I know well, they start also producing this kind of material. In China also. And when China will come, it will be difficult because, or maybe good, I don't know, because I'm sure that we can have low-cost nanocellulose, which can broaden the application most probably.
So, while discussing the packaging application, you said that this nanocellulose based can replace petroleum based
Can replace, sorry?
petroleum based packaging.
Yes.
So if we prepare films with petroleum based PCL and a film with cellulose nanocrystals or fiber, so we are expecting better mechanical properties and barrier properties for the cellulose based films.
Yes, you mean a composite of PCL and
Yeah,
nanocellulose?
yeah.
I don't
No,
know if,
neat PCL and a composite with cellulose.
yes, a composite, but with
Yeah.
which kind of matrix? PCL?
Yeah,
Also.
maybe.
Okay.
Yeah.
Yeah.
So, what to expect? Which will be better in terms
When
of
comparing neat PCL and the
yeah.
composite, so we expect improved mechanical properties,
But
mainly.
is it possible to completely replace this petrochemical based polymers and completely move to a biocide and have the similar properties? Like
Yes, and even better properties, at least in terms of stiffness. Because PCL is maybe not a very good example. Because PCL, polycaprolactone, is biodegradable, but it is not bio-based. So I don't know if it's a good example. In fact, the objective is to, for many companies, is to use only nanocellulose, no matrix. So only cellulose nanofibrils. The problem is that, of course, we can have good mechanical properties of the nanopaper. We can have barrier properties, but not in high relative humidity condition. So I don't know if it's very good for Kerala. And one of the problem also is sensitivity to water, of course, that degrade the barrier properties, but also the flexibility, because the material is stiff, but the flexibility is not so good. But most probably it's possible to use some plasticizer to improve this property.
So, while going through the literature, nowadays the work is mainly using the metrics as PBAT or PCL based petrochemical based polymers as the metrics, and we are incorporating some bio based fillers.
Yes, it's an
So,
option.
yeah.
Yes, yes, it's an option, but the problem is that for some application, it's important to have a transparent film for packaging. So it means that it's necessary to use an amorphous polymer matrix. Otherwise, it's opaque. But yes, of course, it's possible to combine a polymer with nanocellulose, of course. And the advantage is that you can limit the sensitivity to water because there is no direct contact between cellulose and the atmosphere.
Thank you.
Any more questions? So, how does this CNF react to difference in friction? Like, is it able to withstand frictional things properly? Like, very high friction and all?
Sorry, I didn't understand the question.
Sir, is it possible for the cellulose nanofibrils to withstand high friction and pressure?
To extend high
Friction.
friction? Good question.
For space applications,
Yeah.
there will be a lot of change in frictions. Like, so is it able to withstand
Friction, not friction. Friction.
friction?
What do you mean by friction? Resistance
Yes.
to yes? I don't know. I think the properties are not so bad for nanocellulose. I don't know exactly. I have to say I don't know.
So, do you think going for a bio-based material, there would be exploitation for the natural resources? So, do you think that would be a case in future?
I think so because yes, this is the way. It can take times, of course, because an important parameter, and I mentioned for biocomposite, is the price. Of course, when we have a petroleum-based polymer with good processability, with good properties, at a good price, what do you want to change? But yes, it's probably the future, and we can imagine that the price of biopolymers and the price of nanocellulose, so it is expected to decrease. So meaning that the applicability should be favored in these conditions. And there is a very high demand also, you know, from the government and from the consumer to use more sustainable product. And this is also an important pressure.
Thank you, Professor. Any more questions?
Professor, this biocomposite, how good in antimicrobial properties? Antimicrobial properties, how much good is this one? Antimicrobial, antibacterial. Yeah.
Uh, so not too much, but it's possible to use additives like chitosan or silver nanoparticles and so on. And there are many research in this field. So you can easily anchor silver nanoparticles on the surface of the nanofibrils to provide antibacterial, antimicrobial properties.
Thank you.
Sir, up to my knowledge, what I got is you are making the nanocellulose crystals, nanocellulose fibrils from the existing plant, like not from the leaves or sticks which is shed from the plant, right? Is it possible to synthesize such kind of things from the shed leaves, kind of?
Sorry, I do not
I'm
understand.
Like the nanocellulose crystals, nanocellulose fibrils, which you synthesized were from the existing plants and trees, not from the shed leaves kind of. I mean,
Byproduct or what?
yeah, I'm dried leaves, leaves shed from the trees.
No, no, it's not only from the trees. It can be from any source of cellulose. Leaves, for example. I know that there is a startup which is producing nanocellulose from dead leaves. So it's an abundant resource, of course, and it's free, just the transportation, but yes, yes. I don't remember where is this company. Maybe in the Netherlands. I don't remember, but yes.
Professor, first of all, thanks for introducing us to this world of cellulose, starch, and nanocellulose. I was completely unaware of this area. And yeah, I hope all will agree with me that this would have, I mean, this really benefited a bunch of students over here. And I wish more participants were there for this GYAN program. More and more students would have been benefited because you're the expert in this area. Coming to the question, I have one question regarding the electronics area,
Yes.
the 16th and 17th slide probably. So, as you know, for the case of organic solar cell, the substrate that was normally used is the ITO, indium tin oxide.
Yeah.
And now researchers are thinking of replacing it with the nanocellulose. Some papers are there. So, but it's not conductive.
It's
I
not.
mean, the substrate is not conducting. The nanocellulose, is it conducting? I don't.
Sorry, it is?
Is the nanocellulose substrate conducting just as the indium tin
No, it's
oxide?
not conductive. No, no, it's on the contrary, it's an insulation layer. But it can be conductive. It can be conductive. You just have to add some conductive particles
Okay.
or to add a conductive polymer.
Oh.
You can have this substrate with conductive properties. Yes. But of course, not pure cellulose. It is not conductive.
Yeah,
Mainly the objective for electronics is not to have conductive properties.
okay.
It's mainly a substrate for insulation.
Okay. Yeah, I was thinking of the future of this using of renewable nanocellulose as the substrate for organic solar cell.
Yes.
So it has a great future, according to you, right?
Yeah, I think that there are many promising applications in this field. There is a lab which is very close to Grenoble. In fact, France or Europe, compared to India, it's very small and many different countries close. There is a city which is Chambéry, which is, I think, 60 kilometers from Grenoble, so it's very close. And there is a big lab working on solar cells. And so they contacted me a few years ago. I don't know where they are now, but for sure there are many applications in this field.
Thank you.
Any more questions? So let us thank Professor Allen for his wonderful lecture throughout all the 5 days.
Thank
He was
you.
so patient and so friendly to us. Thank you, Professor.